You get a walk. Oh, thank you for being nice. Thank you so much. Mm-hmm. Okay. I am. So imagine I just like for each variable. So that's what yeah, so that's what Mhm. Okay. Good morning, everyone. I want to welcome you to another statistical class. Let me say today, because I have a talk coming up in few minutes, I'm only going to have a cameo appearance here today. So, it's just going to be, I'm only going to spend less than 20 minutes in this lecture. Okay. Uh, my, my talk is taking place today, 11 a.m. Okay. 11 a.m. at Ford or 150. Okay. And you can see the time is 10:10. Okay. So, I want to welcome you into categorical predictors. The other time on Monday, we actually introduced you to regression modeling. And of course, I walk you through uh, how to specify regression model and how I think I also walk you through how to derive the ordinary least square formula that we can use to estimate parameters. But today, what if in a situation where uh, all the explanatory variables, they are all categorical. Of course, the one we did on Monday was a combination of categorical and quantitative predictors. But situation where you know all the explanatory variables, okay, if they are not quantitative, they are all categorical. We also call them qualitative. Okay, we call them qualitative. Okay, so what are we going to do? in sel, we select, how is a model going to look like? Now, let me tell you this. Uh, we need to be guided on how to handle a situation like that because we don't want to fall into a dummy variable trap. We don't want to fall into a dummy variable trap. A dummy variable trap, what do I mean by that? We don't because we expect that the levels of the categorical variables they are expected to add up to one. Okay. And if they add up to one, if I have, for instance, I have k categories, if a variable, okay, is categorical and it has k number of levels, I'm not going to specify all the k. I have to specify k minus one. For instance, if I have 7 categories, I'm going to specify 6. The other category will be referenced. Does that make sense? The reason why we actually going to do that, if we use all of them, we're going to run into dummy variable trap, and dummy variable trap will lead us into a problem of perfect multicollinearity. Perfect multicollinearity. Because the levels of the categorical variables, they will be correlating because they all added up to one. They all added up to one. If I use all of them, okay, that would create a problem of estimation. Because if I have a perfect multicollinearity, okay, it means the design matrix is going to be singular. If the design matrix is singular, I will not be able to find the inverse. You remember the other time, well, I gave you this formula. We derived this formula. Okay, this is the formula if I want to figure out my beta naught cap, my beta 1 cap, my beta 2 cap, and so on, up to beta 2 cap, p cap. Okay, now in that situation, the S prime X inverse would be singular. If it is singular, the singular means its determinant will be 0. If the determinant is 0, then I will not be able to find the inverse. If I'm not able to find the inverse, I'm not going to have this one done. It means I will not be able to estimate the parameter in my linear regression model. If I'm not able to estimate parameters in my linear regression model, then it means there's no way I'm going to achieve my objective. Does that make sense? Now, I give an example here where we got um, the categorical variable, we got 7 levels. I mean, well, we got you can see the levels of that. But at the end of the day, let's say for this, if you take a look at what we have here, or give me 1 second. If you look at what is here, you're actually going to see that they are 3 in number, right? BC, WC, and PROF, right? How many? 3. Okay. Now I can decide to choose 2 and make the other one reference if I'm choosing BC and WC. Okay. Now, if you take a look at this, BC is here, right? It's going to be 1, right? WC is not here. This is 0. Okay. You take a look at it. BC is here 1. Can you see that? 1. WC is not here 0. When I come to WC, under that is going to be 0. Here is going to be 1. When I come to the other one that I said I want to reference, it's going to be 0, 0 at both sides. You see that? 0 here is not in BC, it's not in WC. Okay, and so on like that. Now, you will now see that whenever prof come up, okay, it's going to be 0, 0. Okay, with that, I can reference that. Okay, we normally reference the level of the category of the categorical variable that we assume is the lowest level. Okay, and if I want to rewrite my model, okay, don't forget the other time the Y is prestige. I'm looking at the effect of education being women, but we have additional explanatory variable that we believe will have effect on prestige, okay? But the categorical variable, okay, we don't want to use it. It has a three major level. If we use all the three major level within the categorical variable, we're actually going to end up, into a dummy variable trap that will lead us into a situation of linearly dependent. We don't want linearly dependent. Okay, and that is going to lead us to problem of perfect multicollinearity. Multicollinearity is when they interact perfectly. We don't want situation where the explanatory variables are going to interact perfectly. Is actually going to be problematic to the model. And at the end of the day, what do you see? I only use type BC and type WC, but where is the prof? Okay, the other level that is the prof is being referenced. Does that make sense? But if I want to interpret, let's say for instance, if I want to interpret type BC, for instance, in this model, the coefficient associated with type BC is beta 3, right? If I want to interpret type BC, the way I'm going to interpret that type BC, it should be in relative to the other level of the variable that I reference. Prof. It's going to be relative to that. Okay. If I want to interpret WC, it's also going to be relative to the other variable that was referenced. Does that make sense? And the design matrix for that, let me tell you this. If I want to use this formula, you know what is very, very important? Okay, what is important is design matrix X. If I get X, I will be able to get the transpose. Okay, I will be able to get this side, right? Multiplying this by that, right? Then I will be able to get the inverse. Okay, this Y remains Y vector. Okay, now the design matrix S need to be correctly captured. Okay, if you really, now I need you to pay attention now. Okay, I need you to pay attention now. Okay, this guy is our design matrix X based on this model. That's a design matrix X. In the design matrix X, I want to explain the design matrix X, and I need you to pay attention. Oh my God. I'm actually seeing in the first column, I'm seeing something in the first column, 1111 that is repeated. That is for the intercept. Does that make sense? Okay. There's intercept in the model. The first column is going to be 111111 or 2. What is the coefficient? Okay. If I write it in scalar form, if I, you know, in a matrix form, this is the model. Okay, in a scalar form, you're actually going to see what I'm talking about. The reason for 1111. In a scalar form, y equal to beta naught plus beta 1 x1, beta 2 s2 until I get to beta p sp plus the error. What is the coefficient of this? 1. Does that make sense? That's why you have 1111 or 2. Then the second one is, okay, what is the data on education for each observation? Okay, don't forget in my model, okay, education is here. Okay, being the percentage of women, okay, the percentage of women. Now, this is the domain variable 1. Don't forget, this domain variable, we got 3 levels initially. You are not going to use all the 3. The formula is going to be, if I have k numbers of domain variables, then the one I'm going to appear in my model will be k minus 1. Where is the other one? The other one is being referenced. Is there any question? Now, the design matrix, you can see 1, 0. Okay, is what we formulate here. Okay, it's like we have worked with 7 or maybe 7 observations. Okay. The first person in the observation has a type BC. There are 3 levels of type. Okay. When he has a type BC, okay, that is going to be 1, 0. Does that make sense? So this is what I actually put right here. Then we have an extended. The more explanatory variables you have, the more your matrix S is going to be extending. Any question with that? In a regression model, after specifying your model, you need to be able to have your design matrix correctly specified. Does that make sense? Okay. Before I go, I will give you another example. Let's say, for instance, in my model, I'm considering the categorical variable, maybe education. Okay. I have high school. Okay. Undergraduate, 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 then graduate. Okay. In my model, okay, if I'm looking at the effect of Y, I'm actually going to have this one, undergraduate. Let me call this U, and this is G, and this is H. Okay, plus B2 graduate plus the error. Where is the high school? The high school is being referenced. Does that make sense? Why do I reference the high school? Because it has the low, is, when you compare the levels, it is the lowest, when you talk about education. Okay, among the one compared. Okay, now, if I want to, for instance, this guy, this beta one here, you know what it measures? It measures effect of undergraduate compared to high school. You know what this guy measure? Effect of graduate compared to high school. When you are interpreting, okay, the parameter associated with the other level of categorical variable, that will be in comparison to the level you actually reference. I'll continue from here on Friday. I'm going directly to my talk. Is there any question based on what we did right now? Any question? Okay, like I said, you are invited to my talk. I'm going straight to Ford or 150. See you on Friday. Bye for now, everyone.